Okay. Okay, so as I said before, choose your x-axis, choose your y-axis. Your angle should be with respect to your x-axis, okay? Because it helps you to solve your question, okay? And then apply Newton's law equation for each component. Is it in equilibrium? Is it not in equilibrium? Solve the simultaneous equation, state your final answer. Do not forget units. Okay, so the step to solving this is free body diagram, condition, if it's equilibrium or not. Third is equation, and then solve it. Condition. Okay, let's do one really quickly. So a boy of mass 35 kilograms stands on a weighing machine inside a lift. Tak tahulah kenapa dia nak juga. What will be the reading of the machine while the lift is accelerating upward? And B, moving down at a constant acceleration of 2 meter per second squared. Okay, let me do this in Word. Kejap Copy, how do I copy? Escape, this one. Okay, let's do this here. Okay, so a boy of mass 35 kilograms. So our mass is 35. So what is he doing? Like I said, always try to sketch the best you can. If you have terrible drawing like me, it's fine. You still can solve it, but it's just ugly. Okay, so this is, let's say this is Akil. Ni Akil So Akil tiba-tiba dia nak bawa weighing scale masuk dalam lift. Tak tahulah kenapa. But now he's curious. What will happen to the weighing scale if he accelerates upwards? And what will happen to the weighing scale if he accelerates downward? Okay. Akil has given you a problem now. Now you have to solve it. Okay, so let's do this. This is our situation here. Let's draw a free body diagram on Akil. So, okay, warna lain lah. So we have reaction force. Alah, kenapa hijau juga? Kejap. Let's use a different color. Blue. Okay, this is my center. This is Akil's center of mass. And then Akil will have a reaction because he's on the ground. He is not floating. And then he will have weight because he has mass. Okay, he's not a ghost. And then what else? What else do we have? Do we have friction? Do we have friction or not?
No.
Why doesn't Akil have friction?
No.
Siapa yang jawab tu? So why doesn't he have friction?
Because the lift is technically in contact with the air.
Technically contact with the
Sebab dia
air.
tak gerak kanan kiri.
Sebab dia tak
Sebab dia tak bergerak.
Betul.
Sebab dia tak ada contact.
Sebab dia tak ada contact, yes. So he's only standing there. He's not, tak ada motion lah. In the x direction, there's no motion. And the lift is basically doing the moving. So there's no friction going on for Akil. Kita concern dengan Akil je sekarang ni. Kita tak kisah pasal lift lagi. Okay. Now, we have forces in the y. Our forces in the x are non-existent. We don't have friction. So we are good to go. Okay, so free body diagram, check. Number 2, state the condition. The condition is fx is 0 because it's not moving in the x direction. There's no acceleration in the x direction. And in the y direction, we have acceleration upwards, right? So assuming that I say, okay, going upwards is positive, going downwards is negative. So my acceleration is positive ma. So this equation becomes positive ma. Okay? Ni condition, belum equation lagi. So condition dia, I'm not moving in the x, so it's in equilibrium. I am moving in the y, so it is equal to ma. Okay. Third thing to do is equation. So fx is equal to 0 and I don't have any forces in there, so let's just ignore it first. Sorry, kita ada r minus mg. Sorry, kenapa saya nak ignore ni? Ada je. Okay, R minus mg, right? Do we have Akil's mass? Yes, Akil is only 35 kilogram. Are you really 35 kilogram? 35, 9.81. Okay, so now we can solve for R. What is R? R is, wait, what am I doing? This is X.
Doktor, RMG tu bukan FY ke?
Betul-betul, saya silap. Baru nak cakap. Okay, sorry, my bad. So Fx is 0. Saya nak cakap pasal Fy. Okay, Fy, sorry. Fy is positive MA because that is our condition. We are not in equilibrium. Okay, sorry. Okay, now our equation is positive R minus W. Positive R because I am going upwards. I defined this tadi earlier when I decided on my MA. My MA is going upward, so it was a positive. My R is going upward, so it's a positive. And then my weight is mg. Okay, negative. Fy equals to ma. So this equation equals to ma. Okay, everyone following me so far? Sorry for the confusion tadi.
Yes.
Yes.
Okay, tak confused tau. Jangan confused. Confused tak? Takut pula. Silap cakap tadi. Okay. So MA, we don't know what it is. We know the mass of Akil is berapa tadi? 35. Akil weighs 35. And we don't know what our acceleration is. We don't know our R is. Do we know our R? No. Do we have our mass? Yes, 35. We have our G, 9.81. We actually have our A. Forgot. So that is positive 2, right? Positive 2 going upwards. So R is 273.35 Newton. So I solved for my, apa aku buat ni? Sorry. Sorry. This is not the answer. The answer is 413. Macam ni lah betul-betul. Saya pun laluk juga. Okay. 4. Come on, cooperate. 413.35. Can someone check if I got this right? I might calculated this wrong. So this is 35 times 2 plus 35 times 9.81. Betul eh? Okay, so
Doktor, yang gravity tu tak boleh letak negatif ke?
tak perlu. Remember I told you for free body diagram, you don't have to put in the negative. Your negative is given in your equation, which is this guy. Ingat tak? Saya cerita.
Okay. Ingat. Thank you, doktor.
Okay. So now your R is 413.35. Okay. What does Akil feel? Okay, ingat weight is equal to mg. Weight is 30, 35. Okay, weight is 35 times 9.81. How much is this? What is the weight? Weight is... Can anyone calculate this for me? I don't have a calculator.
343.35.
Okay, 343.35. Okay, on normal circumstances, Akil feels R that is equal to mg. Betul tak? This is on normal days. Where Akil does not care about getting into a lift. This is what Akil feels. R equals to mg because he is in equilibrium. Betul tak? When Akil is in equilibrium, R equals to mg, which means that R is 343.35 Newton. But Akil tiba-tiba hari ni nak masuk lift. So now he feels R equals to 413.35, heavier than what he normally feels. What does Akil feel? Does Akil feel lighter or heavier?
Lighter.
He actually,
Lighter.
he feels heavier.
Lighter.
He feels heavier. Because why?
Heavier.
Because the lift's moving up.
Because the lift is moving up. Betul. Tapi bila korang masuk lift, betul lift tu naik atas, korang rasa berat ke tak?
Berat. Rasa ringan bila dia nak turun bawah.
Betul. Bila kita turun bawah kita rasa ringan, bila kita naik atas kita rasa berat because
Rasa kurus.
our apparent weight is heavier. Ni apparent apparent tu macam acah-acah lah. Acah berat lah pula. Apparent tu macam ya tapi bukan. That is what apparent means. Macam je tapi bukan. So dia macam acah-acah berat. Akhir acah-acah berat bila lift tu naik atas dia rasa macam berat sikit lah daripada biasa. Macam tu. Okay, so that is when your R is greater than mg or weight. So you feel heavier inside the lift. And the opposite case for when the lift is moving downwards. Okay, let's see.
Tapi kan doktor, R tu kan macam motion upward. So bukan patut dia macam contohnya kalau kita angkat barang. So macam kita angkat barang macam kalau R dia lebih tinggi daripada ke bawah tu, barang tu kan macam naik atas. So macam benda tu, faham tak? So kenapa dia rasa lagi berat?
Kenapa dia rasa lagi berat? Yang awak cerita tu is a box kan? Awak cerita a box bila angkat ada R, ada weight. Bila angkat kan R dah tak ada. Tak ada, no contact. Betul tak? Bila angkat. It is off the ground. There's no contact, no R. Lain situasi dia daripada angkat kotak. Kita dalam lift, apa yang kita rasa tu lain daripada yang kotak tu rasa. Kotak tu kena angkat.
Contohnya macam ni doktor, sebab contohnya macam dalam lift. Okay, let's say kalau lift tu bergerak ke atas, R dia akan lagi besar dari dia punya mg. Tapi kalau bergerak ke bawah, mg dia akan lebih besar daripada R. Tapi R tu kan macam positive direction, mg tu kan negative direction ke bawah. So kenapa dia bila kita rasa tu dia macam vice versa?
Oh, okay, faham. Because R ni kan perasaan dia. Okay, sekarang ni awak rasa ke apa-apa kat badan awak? Awak rasa berat ke, rasa ringan ke, rasa sama je kan?
Sama.
Sama because R equals to mg. Bila R ada pertambahan, awak akan rasa that extra pertambahan tu. Walaupun dia, okay, saya faham apa yang awak cakap. Awak benda tu ke atas tapi kenapa rasa berat kan? Sebab apa yang kita rasa R ni is apa yang kita rasa sebenarnya. Macam mana cakap? Apparent weight. Macam mana nak cerita?
Doctor, it's because R is acting on us, right?
R is acting on us, betul. Tapi persoalan dia sekarang ni, if R is upward, kenapa kita rasa berat? Sebab our body perceive this as our weight. Perceive. Dia rasa benda ni weight. Sebenarnya weight kita mg. But this is our perception. What our body feels. R as weight. So bila R tinggi, kita rasa macam weight kita berat. Perception. Yes, R is acting on us, betul. But itulah, it's going upwards. But our body perceive this as weight. Saya tak tahu yang tu kenapa. I don't know if that has anything to do with biology though.
Okay, thank you doctor.
Okay. So ni perception Our body perceive this as weight. Walaupun dia acting upwards. If it is greater than W, if R is greater than W, we will feel heavy. Heavy, And if R is less than W, we feel like, oh, something is missing. We will feel lighter. Nak menguap tapi tak jadi. Okay, we will feel lighter. Ya Allah tulisan, sorry. We will feel lighter. Okay. Lighter. Kenapa dengan touch sensor saya ni? Okay, lighter. Okay, let's do for accelerating downwards. Walaupun macam senang je kan. Tapi I'm sure someone will ask me later. So let's just do it. So R we have going upwards, W is downwards, and it says going. So our free body diagram is like this, but we have acceleration going downwards now. How do I label the acceleration? I label it like with a small arrow indicating the direction of acceleration equals to 2. Macam tu Here, how did I do this? Okay, I forgot to label it. So here I'm going to label the acceleration like this. A equals to 2. Again, I'm not going to put any positive or negative in my free body diagram, only arrows to indicate direction. So A equals to 2 going upward. A equals to 2 going downwards. Here, this is your free body diagram. Check. Okay, next one, condition. We know that our fx is equal to 0. Our fy is now equal to minus ma. Assuming that positive is going upward, downwards is negative. Okay, we set this convention ourselves. So fy equals to minus ma, sama juga macam tadi, equals to, what is the equation? R goes up, positive, W is down, so minus mg. So your equation is minus ma equals to positive R minus mg, where R is just ma plus mg. M is 35, 2 is a positive, A is 2 plus 35 9.81. Ni minus lah. Sorry. This is a minus. Betul kan?
Minus dekat MA, doktor.
Minus dekat M8, sorry. Saya positif kat sana. Okay, betul-betul. Thank you. Minus dekat MA, this is a positive. Okay. This is R positive. I'm bringing this guy over here. So my MA is minus, my MG is positive. Okay, thank you. So jawapan R now is 273 ke? 273.35 Newton. 273.35 Newton, and we know that our weight is mg. 35 times 9.81 was something close to 350 and approximately 350 lah. So R is less than weight. Now Akil feels lighter. Because why? R is our perceived weight. Kita rasa weight tapi sebenarnya bukan. Terasa je macam feels lighter than normal. Okay, any questions for me for this question? Is everyone okay? No question
Doktor,
Yeah.
adakah waktu lift tu sepanjang dia turun tu kita akan terus kekal merasa lighter?
Sepanjang dia tak, sebab acceleration dia tu akan berkurangan kan? Sampai kita, okay. I think this was covered in the video. Kejap. Okay, imagine a lift. Imagine a lift. So this is a lift kan? Allah, kenapa lift saya macam tu? Okay, so this is me in the lift. Saya pakai skirt kali ni. Okay, so this is me in the lift. Saya tekan nombor, I am at left floor 3. Kan, saya nak turun ke G. Want to go to G, ground. So I press the G button. What happens? I start going down, kan? When I start going down, dia tak ada laju sangat kan? So my V, let's say is 3 lah, contoh Saya sebenarnya tak tahu pun velocity lift berapa. Okay, but at midpoint towards G, contohnya kat floor 1, my velocity is 5. And then bila dah sampai G, sebelum sampai G tu, my velocity is 2. Sebab why? I'm trying to, the lift is trying to stop. So it will want to have a 0 velocity lah kan. At this point, lift wants to stop. Lift wants to start. Lift wants to start motion lah. Start moving. Dekat tengah-tengah, it will usually be lift is at highest velocity. Okay. So no, the acceleration, the velocity is not constant, the acceleration pun tak semestinya constant. So it really depends on the question sebenarnya. But to make things easy, they will say okay, acceleration is constant at 2. Okay, but actually in reality we know that it's not the case because the velocity keeps on changing. When we are trying to stop the lift, the acceleration is different. When we are trying to start, the acceleration is different juga. Does that make sense? Hello? Is everyone
Yes,
okay?
doctor.
But this part you don't have to know just part tadi je. Yang ni macam life. Okay, life lesson. We know that acceleration is actually not constant. This is just to help you understand how to solve. Is that okay?
Yeah.
Okay, in your Instagram, if you follow Unit Physics as per, they covered the part when the lift starts to move and when the lift is going to stop. Sekejap. Let me check. Lift elevator cases. Ada. Elevator cases for not moving, don't move, moving, about to stop. So it covers all these different situations. You can take a look at the Instagram now. Those are different types of problems that you can take a look at. Korang still dengar ke? Hujan ni kuat juga lah.
Boleh.
Boleh?
Dengar.
Okay. Okay, so now let's go on to the next example. Example 3.6. A 15 kilogram box is released on a 32 degrees incline and accelerates down the incline at 0.3. Find the friction force impeding its motion. What is its coefficient of kinetic? Okay, let's do this one now. Okay, ni ada kaitan dengan friction. Okay. Let's draw the free body diagram first. 15 kilogram box. So mass equals to 15. Incline is 32. Accelerates down, incline. So at 0.3. Kenapa tulisan saya teruk sangat ni? Kejap. I think my pen is not responding well. Kejap Okay. Data is 32. Apa tadi? Accelerates 0.3. Okay. Nak panggil siapa buat free body diagram? Can I give you 5 minutes to draw me the free body diagram and then tangkap gambar, hantar ke WhatsApp? I'm gonna pick one. 5 minutes to draw the free body diagram. Who is my lucky winner? Kalau saya tak suruh ni, semua orang tak buat. Okay. 5 minutes from now is 253. Free body diagram je. 253. K20. Wow, lajunya. Thank you. Oh mak kau terkejut. Sorry buruk. Tak apa, saya maafkan buruk-buruk ni. Okay, so which one is correct? Is it Meon yang sebut. Or Zul Hakim. Takut salah.
Mayon.
Meon betul? Kenapa Zul Hakim salah?
Mayon betul.
Kenapa dia betul? And kenapa lagi seorang salah? Apa ni angle macam ni? Sekejap. Tak nampak. Down incline friction.
Dia kata, saya buat macam Hakim punya.
Tu je jawapan sebab betul.
Mayon betul.
Kenapa Meon betul? Cuba bagi tahu
Sebab
kenapa.
dia tukar dengan mg cos theta.
Sebab dia
Maybe?
sebab dia bukan mg cos theta. Mana acceleration korang ni?
Doktor, actually dua-dua betul. Tapi Mion punya lebih lengkap.
Actually dua-dua betul tapi Meon punya lagi lengkap. Meon punya mana? Meon punya lagi
Yes, sebab saya punya tak theta.
sebab awak punya tak ada theta.
Kenapa saya rasa Mi'on punya salah?
Where's your
sekejap.
acceleration?
Saya rasa Mayon betul.
Betul. Pening kepala aku.
So, where's your acceleration? Kenapa tak ada arrow kecil tu? Ya Allah, Faiz, kenapa angle awak kat situ? Ke saya yang salah tengok ni? Sekejap. Confused.
Oh tak boleh angle kat situ.
Boleh lah, tapi kenapa nak buat kat situ?
Sebab buat dekat bawah macam tak comel.
Ya. Okay. Tapi nanti awak yang confused, saya tak tahu
Tapi kan doktor nak tulis A tu nak tulis kat mana?
Like I said, look, buat arrow kecil je indicating where. Indicating the motion. So mana-mana je
Dekat-dekat
asal
dengan F down
dekat-dekat dengan F down. Kejap kita tengok dulu kawan-kawan buat macam mana. Ada tak orang yang buat A? Oh ada. Tak ada. Siapa yang buat A? Tak ada orang. Kenapa tak ada orang buat A? Penat saya ajar tadi.
Saya buat doktor.
Mana? Tak ada pun. Saya tak nampak.
Hakim ada doktor.
Zul Hakim ke Hakim? Oh
Hakim.
Oh
Hakim
sorry.
Zamani.
Sorry Hakim. Saya tak nampak.
Kecil je A dia.
Okay betul. Ada.
Abang punya?
Siapa?
Diamlah ZB.
Siapa yang gelak tu?
Aira.
Okay dah. Semua orang dah dapat dah? Kalau rasa sama tak payahlah hantar balik. Jahat tak? Okay A boleh lah. Okay lah. Siapa ni? Bell. Okay Bell. Correct Bell. Reza Arif buat R W F S. What is FS? Reza, what is FS? MG. Okay, don't.
Silap doktor. FK.
Ni kenapa awak punya sama macam don't know what I did. Sekejap. Rajin pula korang hantar ni. Kan tak ada siapa nak hantar. A equals to mana FD ni apa? Oh F down. Okay fine.
Doctor,
Yeah.
I have a question, doctor. That the one that turun bawah, right? That one is like the net force, right?
Not necessarily.
If we minus it with friction,
If you minus it with friction, yes. Then it becomes
so
unnet.
that force is the MA force,
That force is the MA force. Yeah.
Okay, thank you.
Doktor,
Yeah.
Mason terkeluar.
Mazen terkeluar. Kenapa saya tak dapat request pun?
Lepas tu dia kata tak dapat masuk lagi.
Oh. Sekejap. Macam mana saya nak bagi dia masuk? Saya pun tak tahu. Oops. More. Allow participant. Okay, semua orang dah settle kan? Hantar saya ni. Sekejap, macam mana saya nak kecilkan? Pakai. Okay, let's discuss.
Betul yang mana satu betul?
Mana satu betul? Sekejap, tak check lagi. Rajin pula korang hantar. Sekejap.
Semua betul.
Yelah Hakim.
Dia kenapa emo ni?
Aira, kita tutup mic.
Banyak sangat lah, saya tulis lah jawapan saya. Korang tengok sama ke tak? Okay. So angle,
Ambil Hakim punya.
kalau macam ni boleh, incline macam ni pun boleh. Dua-dua betul. Okay, 32 degrees macam ni. 32 degrees macam ni. Okay. And then ada box. Tak lukis box pun tak apa. Tulis letak center of mass dia pun boleh. Okay, and then let's do the R this way. The R for this guy is this way. And your weight, oops. Weight is this way. And this is the weight for this guy. And then it says going down, right? The question says accelerates down the incline. So maksudnya dia menggelongsor ke bawah. Which means that your motion is this way. So your small arrow is A like that or like that. Okay, equals to 0. 0.3. Okay, this one is also equal 0.3. And then we have friction, always opposing motion. Remember, Fk or just F is fine. Okay, F, opposing motion. What else am I missing? Mg cosine theta. If you did not provide me mg cosine theta, it's still correct because why? You are just resolving mg cosine theta. If you know that your w is this way, you should know where your mg cosine theta and your mg sine theta is. Okay, but to be safe, buat je, senang, tak susah pun. Okay, so this is your angle. And for this guy, this is your angle. Cosine theta. So siapa yang betul? Semua betul kecuali yang tak label A. Penat saya ajar. Okay, so that's your answer. Yay, congrats if you got it right. Right? So free body diagram, check. Next one, we need to write the condition. So the condition is...
Free body diagram check.
Hah? Apa? Free body diagram, check.
Tika buat TikTok, doktor.
Okay, so this, for if you decide to use this diagram boleh, if you decide to use the second diagram pun boleh. The jawapan, the answer will be the same. Okay, so if I'm using this diagram, my x is this direction, my y direction is this way. Okay, and then I'm going to assume that this is my positive and this is my positive. So anything that is in this direction is x is positive, and going upwards from this is positive. Ini bukan x, ini positif. Okay, condition fx is ma. I said going this direction is positive. Kejap biar saya padam ni dulu. Confused sekarang. Okay, I said going to the right is positive. So my A is going to the right because I'm going down, right? Acceleration going down. So this equals to MA positive. It's not a negative, it's a positive because it is following this convention. And then what else do I have in my x direction? I have positive mg sine theta, negative friction. Why? Because friction is going the opposite of my convention. My convention is here. Okay. So minus F plus mg sine theta. So my equation is MA equals to minus F plus mg sine theta. Theta is 32. Then this guy, Fy, am I flying? Is my box flying? No. So it's in equilibrium in the y direction. So that condition is 0. Equation is what are the forces in the y direction? It's r positive going down, mg cosine theta. Positive r minus mg cosine theta. So this gives me 0 equals to r minus mg cosine theta. Okay, so r is just mg cosine theta. Okay, so what is the question? Saya tak baca betul-betul. Find the friction force impeding its motion. What is its coefficient of kinetic friction? Before we can find the coefficient, we need to solve for friction first. So friction is equal to F equals to mu r. So to solve friction, we need to know what r is. So r is here, m is 15 and the angle is 32. This is 15.
Tak boleh ke doktor kita guna yang atas tu, MA equal to friction tu, mg sin theta.
Boleh, but you will only solve for F. Terus, boleh juga, boleh. I'm just solving R dulu. Boleh je. We will solve for F. But we need to find the coefficient of friction. So either we kena solve for R juga. Boleh je, boleh je. Okay. So this is cosine 32, which gives me 273.35. Betul ke? Salah. Sekali je. Sekejap. Apa jawapan dia? What's the answer? This one is, what is R? What is R, guys? 1 to 4. 7, 9. Did everyone get this? Hello?
Yes.
Betul? Betul Okay. This is from my Y, from my F net Y, I got to solve R, which is 124.79. From my F net X, so let's see, what can we do with this? So M is 15, 15, okay, 15. Acceleration is 0.3 equals to friction, we don't know, plus 15, 9.81 sine 32. So solving that will give me friction. Solving that will give me friction as 73.48 Newton. So this question, we got it. Check. What is coefficient? So coefficient is, we know F is 73.48. Coefficient, we don't know. R is 124.79. So we can solve for mu. Mu is 0.59. What is the units for mu?
No unit, doctor.
No units, betul. Because why? This guy is Newton, this guy is also Newton. Nothing should be added there, okay? So it's no units. Thank you. Okay, so 7-minute break. Come back at 3:10. Pergilah toilet ke, makan ke apa ke. Ngantuk je. Okay, come back at 3:10.
Doktor boleh scroll balik ke atas tak? Nak tengok jalan kerja sebelum ni.
Boleh?
Thank you.
Yang ni ke?
Bawah sikit.
Yang 3.5 tadi
3.6 tapi
Ni. Yang ni ke?
ya.
Okay. Oops, sorry.
Doctor, I have a question.
Okay.
Is in the module page 47, PBL 3.4.
BL 3.4. Okay.
Yeah, doctor, I tried this question, tapi tak dapat jawapan dia. I seem to be off somewhere, but I cannot like figure out where.
Okay, jap tengok if I have solved it yet. 3.4. Oh, ini. Okay. So for this question, you have to solve F. Kejap. Cuba saya tunjuk ni. Saya tulis lah. Sedang kat gambar. PBL 3.4. Belle, did you get that free body diagram? The F should be horizontal, bukan, it's not parallel to the incline.
Doctor, I got the free body diagram, but I don't understand why F is positioned that way.
Oh, because the question said horizontal force, bukan parallel to the incline. Saja dia nak confuse. Horizontal force kan? Horizontal, parallel to the ground.
So, doctor, horizontal as in the original horizontal that we consider to be horizontal,
Yes,
right?
the original horizontal.
Oh, okay. So that means I got the question wrong. Okay.
Yeah.
Thank you, doctor.
Okay.
Doktor,
Yep.
boleh patah balik dekat free body diagram atas tadi? Scroll balik.
This one?
Saya nak confirmkan yang angle 32 dekat bawah tu memang sama yang dekat bawah kotak tu.
Angle 32 tu memang angle dia kat situ. Dia memang kat bawah kotak.
Okay.
Okay.
Doktor, boleh saya tengok yang jawapan B? Yang kinetic friction coefficient.
Oh, okay, this one. Jawapan dia kena solve dua-dua equation. Sekejap. Mana? Mana dia pergi? Sekejap. Kita buang ke? Oh, okay.
Doctor, Doctor, can you send the method for PBL 3.4?
Method?
Yeah,
Why? You should be able to
because
solve it.
I tried but I didn't get.
Okay, can you send me your working steps? Let me see.
Okay.
Because I got it. I got the answer. Okay, got it, Kabilan. Kabila, where's your complete free body diagram? Where's your condition?
Doktor,
Kabila buat balik soalan ni. Apa dia?
doktor. Sorry for interrupting, but Izu asked me,
Okay.
yang jawapan doktor tu, mana yang A, mana yang B?
Mana yang A,
Thank
mana
you.
yang B? So A
Sebab dia kata, doktor dia campur.
memang campur-campur pun sebab jawapan ni memang kena campur-campur. Sekejap. Tapi kalau kita nak betul-betul separatekan, this would be A. Semua soalan ni kena, semua jawapan ni kena ada untuk jawab A dengan B. So A, this is A. Okay lah, ni part X je lah. But this guy, for B, you need to have this and this. So the entire, semua ni kena ada untuk B. Untuk A boleh lah nak pakai fx je, boleh. But for B, you have to have all of this. So basically buat je lah semua and then solve. Sama je. Kenapa nak beza-bezakan A dengan B? Confused ke apa?
Doktor nak tanya, yang from the answer yang friction 73.4 AM, kenapa dia bukan negatif yang merujuk pada direction dia?
Because we are solving for F. We are not solving for the its direction. Direction tu dah bagi kat sini.
Dah bagi dah.
Kita solve magnitude dia je. Lepas tu kita tengok balik. So F is 73.48. Tengok free body diagram. Okay, it's this way. So that's how you use the answer.
Oh, tak perlu include negatif sebab dia kat free body diagram tu ke belakang.
Unless dia tanya what is the direction of friction. So free friction is 73.48 going up the incline. Macam tu je lah. But your free body diagram patut dah dapat bagi markah dah lah for the direction. Let's say your answer. Apa dia?
Tak, okay.
Jadi tanya.
Thank you.
Okay, let's say your answer for friction is negative 73.48. That means your free body diagram salah. Maksudnya what I'm saying salah tu bukan salah tau, dia salah assumption. So you assume your friction was going upward. Jawapan dapat negative 50, let's say. Maksudnya your friction is actually going this way. Tu je lah maksud dia. If your friction is positive, yes, free body diagram punya arrow betul. Friction dapat negatif. Okay, arrow friction untuk free body diagram salah. Terpatutnya terbalik. Tu je lah.
Oh, so it must refer from the free body diagram.
Yes. So your answer will tell you kalau positif sama macam free body diagram. Kalau negatif terbalik dari free body diagram.
Dan soalan ni pun makan doktor?
Kalau soalan macam ni, soalan macam ni 3 atau 4 kot.
Include markah sekali kat free body diagram tu tak?
Okay, free body diagram selalunya satu markah. Lepas tu equation satu, answer. Sekejap, equation satu, answer betul, 4 kot. 4. Kalau include free body diagram. Okay, is everyone back? Dah 3:13 dah. Okay. Kabilan, you need to do your apa nama dia? Jalan kerja betul-betul lah baru hantar kat saya. Tu salah tu. Kalau awak hantar exam macam tu tak dapat markah. You need to do it completely. Okay.
Yeah, doctor, but the writing I don't know how to do.
But the writing, your free body diagram is also incorrect. You need to have that complete first. Jangan malas buat betul-betul. Baru hantar kat saya.
Okay.
Okay, let's continue with this example. Okay, 2 identical boxes, each of mass 30 kg are connected by a cord over a smooth pulley. So remember, if your pulley is smooth, there is no friction, you can basically ignore. Boleh ignore. Okay. One of the boxes is on a horizontal table, and the other on an inclined surface 30 degrees. So this is 30 degrees with the horizontal. If the coefficient of friction on both surfaces is 0.2, Okay. Calculate the acceleration. Calculate the acceleration of the box, what is A, and the tension of the cord, what is T. Okay, so that is your question. So let's copy this first. Okay. U, A, and whoops. Oh, okay, bagus. Copy je lah semua. Word. Kenapa dia macam ni? Whoops. Kita bagi jawapan pula. Picture format. Crop. Kasi jawapan pun bukan korang tahu pun. Kena ajar juga. Okay. Let's do this. Okay. So we have two free body diagrams because we have two center of masses, kan? We are ignoring pulley because it is smooth. So let's do mass 1 first. Center of mass are going up, are going up here. R dia lain-lain sebab this guy is in contact with the horizontal, this guy is in contact with an incline. R must always be 90 degrees to the surface. Again, R must be 90 degrees to the surface. So what is 90 degrees? If you extend it, it will be right at a right angle to the surface. Okay, kalau yang ni hari tu ada orang salah yang ni. So please take note of this. Okay, let's do this one. So R is this way, and then we have weight, W. Weight is the same. Doesn't matter which surface you are on, weight must always point downwards. And then we have tension. We are ignoring the pulley because it is smooth, but if we were not to ignore it, it will go like this. This is our tension, which means that this is our tension. Tension always points towards the center of the rope or the string. Okay, so that is our tension. So ni boleh buang because we are not interested in that. This is our tension. Okay, so if the coefficient of friction, if the coefficient of friction, calculate the acceleration of the box and the tension of the cord. So it's saying there is acceleration, but we don't know which way it is going. So I will make an assumption that acceleration is going down here. If my box is going down here, it will drag this box because it is connected by a string. So this guy will go will have an acceleration to the right. This box will have an acceleration downwards. This box will have an acceleration to the right. Okay, so if my motion is to the right, my friction is to the
left.
To the left, yes. It is opposing the motion. So I will put my F like that. So in this direction, there is tension and there's also friction. Okay, so this is our two free body diagrams. Any questions about this?
Doktor, tension dengan friction dia akan sama ke? Dia punya value?
No. Tak sama. Boleh sama tapi macam nak cakap it's not the same thing. It's not the same thing. So value dia mungkin sama, value dia mungkin tak sama, but tension and friction are two different things.
Thank you, Doktor.
Okay. So
Doktor.
body diagram. Yep.
Ya, yang box M1 tu dia tak ada guna cos dengan sin kan?
Ada? Mana yang ni?
Ada. Yang box kat yang rata tu.
Tak ada. Sebab dia tak ada angle. So you don't have to resolve. So this guy is everything is in the X, everything is in the Y. This guy we are assuming we have an x here. So that means that we have to resolve our y, w here and our w here. So wx, wy here. Betul tak? Yang ni dah memang sedia ada dalam y direction. Yang ni kita kena resolve supaya dia berada dalam y direction kita dan x direction kita. So now we have two axes. For this guy, this is our x-axis and this is our y-axis. And this guy, this is our x and this is our y. Because they are two different free body diagrams. So you can do that.
Betul.
Mm-hmm.
Untuk dua-dua.
Ya. Yeah. Tak dengar.
Dari normal dia untuk dua-dua box sama ke?
Tak. Tak sama. Okay, so let's continue. So no questions on the free body diagram dah All answered? Okay, free body diagram, check. Second, condition. Let's say, yang ni apa? Sekejap, tengok balik slide. This is mass 1 and this is mass 2. Okay. Mass 1. Condition for mass 1. What is the condition? Can anyone tell me? Okay, siapa? Saya panggil lah. Tak ada orang nak menjawab ni. Can I get Balkis? What is the condition for my fx? Balkis Ashik. Are you there?
Hello.
Hello?
Hello.
Dengar.
Condition. The condition of the box.
In the x direction, is it in equilibrium or not?
No, it's not in the equilibrium.
Okay, it's not in equilibrium. Maksudnya it is equal to this one. MA. Positive or negative?
Positive.
Positive. Okay, thank you. Betul. Kalau Balkis jawab negatif pun saya terima. Tapi kalau dia jawab negatif maksudnya semua to the left will be positive. Semua to the right will be negative. Kalau dia cakap MA ni negatif. Okay, maksudnya to the right is negative, so MA negatif. Boleh. Tapi confused lah. But it's not wrong. Okay, so let's just stick with what is easy. So to the right is positive, upwards is positive. Macam biasa. Okay, so MA is going to the right, so I'm going to say is positive. And then condition for FY. Is my box flying? No, it's not flying, it's just sliding, right? So no motion in the Y direction, which means that my FY is in equilibrium. Okay, balance. Up and down is balance, so I'm not moving. I'm not accelerating in the Y direction, I'm only accelerating in the X. Any questions about condition for mass 1? Okay, Okay, let's talk about mass 2. Condition for mass 2, Husna, what is my fx? Is Husna there?
Yes.
Okay, what is the condition for fx for mass 2?
Positive ME.
Yes, correct. What is the fy?
Fy is R minus mg cosine theta.
Okay, but condition dia apa? Equilibrium or not equilibrium?
Not equilibrium.
Not equilibrium. So
Yes.
it's accelerating in the y direction.
Oh, okay, I'm wrong.
So apa? Equilibrium lah.
Confused.
Equilibrium means balance. Maksudnya tak bergerak. So is it
Oh,
in equilibrium or not?
Equilibrium.
Equilibrium. Okay, thank you. Husna kan tadi?
Yes, yes. Sorry.
Okay. Alright, so we have established our condition so far. So semua orang betul so far. Now let's write our equation. Okay. If you made it this far, congrats. If you have not, if you got this part wrong or the free body diagram wrong, please, you need to revise this until you get it right because you can't solve the equation without getting these two things correctly. Okay, so equation. So now we have fx equals to ma for mass 1. Let's take a look at mass 1 first. So fx equals to ma. What is in my x direction for mass 1? I have positive tension. Okay, wait, let me write the condition dulu. So fx is ma. What do I have in my x direction? I have positive t and I have minus f. Okay, so that these are the two forces that I have. Yang ni bukan, yang ni just direction kan. Okay, so kita buang ni dulu supaya orang tak confuse. Okay. So I only have positive t, which is in the same direction as my A, and minus f, which is the opposite direction as my A. So this gives me an equation MA equals to T minus F. Okay. And then can I solve this? Do I have friction? What am I given? The coefficient of the friction is 0.2. I have the angle, I have the mass. Mass is 30. Coefficient is 0.2. And angle is 30 degrees. Okay. Fy is 0 from here. We already established the condition. So what are the forces in my y? I have R going upwards and W going downwards. So positive R minus mg. So that is equal to 0. So if I were to rewrite this, sorry. Okay, so I will have this equation R minus mg. So this is only for mass 1, baru. Whoa. Okay, so that is mass 1. Okay, let's do mass 2. So mass 2 is, we have the condition, let's write it down. Fx equals to plus ma. Fx equals to plus ma. And what do I have in my x direction? My x direction is here. So I have negative t, negative f, positive mg sine theta. So that is positive mg sine theta minus t minus friction. So this is minus t and minus friction. Okay. Oops. Okay, next. So this will give me an equation looking like this. Kenapa pelik-pelik ni? Okay, MA equals to mg sine theta minus t minus f. Okay, so that was in the x direction. So now we're going to take a look at y. So it is in equilibrium. What is in the y direction here? Positive r minus mg cosine theta. So positive r minus mg cosine theta. So rewriting this, I will get r minus mg cosine theta. So this is my equation. Okay, so any questions for the equation so far? No question? Okay, is everyone okay?
Yes.
Doctor?
Okay.
Yes.
Doktor,
Ya.
Hakim nak tanya.
Okay, tanyalah.
Soalan lain. Tak apalah.
Oh,
Doktor saya nak tanya.
okay. What is it?
Yang dekat equation mass 1 tu MA equals to T tolak F kan. And then yang kat bawah tu, scroll bawah doktor.
Scroll bawah.
Yang tu plus mg sin theta tu ada kenapa ada negatif T tolak F?
Because for mass 2, you have minus friction. You have friction in the opposite way and tension here. Kenapa Awak tak perasan ke macam mana? Tak faham.
Oh.
Ini kan mg.
Oh.
Sin theta. So mg sin theta going downwards, which is what our positive is. So positive, tension and friction, negative, opposite way. Faham ke?
Okay doktor.
Okay. So okay, no questions? Okay. Now that we have the equations, let's plug in numbers. So what do we have? What can we solve first? Ini soalan yang sama ke? So this is equal to 0. So R minus mg. Do we have the mass? We have the mass? Yes, we do. So 30. So boleh solve for R. Saya nak pakai nombor warna lain lah. Okay. Kalau rasa nak solve terus boleh. I'm just helping you understand how we get the equations. Boleh je terus dapat equation ni terus nak solve for R boleh. Tak ada masalah. So R equals to mg. So M is 39.81. So this gives me R as 294.3 Newton. Okay. So if this is R and I have the coefficient of friction, so this guy becomes, mass is 30. I don't know what my acceleration is. I don't know what my T is. I know what my friction is because they given me this coefficient. So coefficient is 0.2. R is 294.3. So this will give me 30A T minus 58.86. Okay, any questions so far? Everyone okay? Okay, I'm gonna continue. Ada question? Tak ada? Okay. So here for mass 2, we can solve for R as well because it's equal to 0. We know what M is, we know what G is, we know what cosine is. So it's just mg cosine theta, right? And M is 30. Cosine is, 9. So that is 9 point, ya Allah. I am very sorry for this lack of penulisan yang cantik. Sekejap. Susah tau bagi tablet. Okay. Okay, 9.81. Cosine, berapa dah? Cosine was 30. Cosine 30. So R is, what is R? What is R? 254. Betul tak? Dapat tak? 87. Okay, so that is your R. Dapat sama Okay, thanks. So R for mass 2 is 254. Tak sama kan? Walaupun mass dorang sama. Mass dorang both are 30 kilogram. Here the question set 2 identical boxes each of mass 30 kilogram. But the R is not the same. Seorang tu tak ada angle, seorang ada angle. So the R is different. Okay, so kalau box ni orang perceive weight dia lain lah. Dia rasa lagi berat ke, lagi ringan ke, tak tahulah. Tapi box ni tak ada perasaan, so dia tak kisah pun. Okay, so next. We have solved for R. So saya akan make this equation better. So let me see. So this is 30A minus M is 30. Oh no, I can solve this terus. So So I know what is mg sine theta. So let's just 39.81 sine of 30 minus t. Do I know my friction? Yes, I do. It is 25487 times 0.2 because the coefficient is the same. Okay, so this gives me an equation looking like this. Kejap. This is 30A minus T plus 96.18. Okay, any questions? If I'm going too fast ke apa ke? Tanya kalau tak clear. Any questions so far? Okay, I'm gonna let you guys absorb that while I erase this. No questions? Wow, semua hebat. No questions? Good. Okay, tak adalah good. Boleh je nak tanya Tak adalah, saya marah pun. Okay, so now I have two equations. Allah. This is my from mass 2 and this guy is from mass 1. Can we equate these two? Yes.
Yes.
Can. Okay, so this is 38 equals to t minus 58.86. This is 30a equals to minus t plus 96.18. I can equate 30a to 30a, boleh. I can equate t to t pun boleh. Mana-mana lah, tak kisah. So here I'm going to do 38 equals to 30a. So this will give me minus t plus 96.18, just this equation. And then this guy is positive t minus 58.86. Positive t minus 58.86. So now I will have 2t equals to berapa tah? Tak tahu. Tak ada calculator pula. 2t equals to berapa Tolong kirakan. 96.
155.
I got 155.04.
155.04. So t equals to 77.52. Betul tak?
Betul, Doktor.
Alright. Any questions so far? Yang rasa confusing, you can ask me. We can address this in class. Okay, So now we have solve for tension. What is the question? Dia suruh solve for tension and acceleration, kan? So we have calculated tension. Now we are asking for acceleration. So here 30A is equal to minus t minus 77.52 plus 96.18. So acceleration is equal to whatever this is divided by 30. That will be 0.62 meter per second squared. Okay, was that okay? Everyone still alive? Are you guys okay?
Yes.
Okay. Thank God.
I'm breathing.
Breathing, thank God. Praise the Lord. Okay, so untuk soalan ni, dia ada soalan yang lebih kurang dengan PBL. Soalan PBL. Which one? Okay, PBL 3.7. Soalan ni lebih kurang. Beza dia is M2 tu bukan atas horizontal. It has an angle. So what I would like you to do is give me the free body diagram, the condition and equation. You don't have to solve it. Tangkap gambar of your jalan kerja, upload it through Putra Blast. I will let you know. So please upload it before Friday. Again, I just want your free body diagram, condition, and then equation. You don't have to solve it. PBL 3.7, page 49. Lengkap. Free body diagram kena lengkap, condition kena lengkap, equation kena lengkap, baru dapat full mark. Okay? Please do that. It's pretty easy and this will be a good revision for your exam, for your test later. Okay, soalan-soalan macam ni lah. Okay. So if that is it, that question. So we are done with chapter 3. Any questions you can ask me later or on through WhatsApp or through class later. Okay, boleh. I'll give you 5-minute break. Then we will start on chapter 4. So 3:45 come back. Questions pun boleh.
Doktor,
Ya.
ada soalan.
Mm-hmm.
Untuk A kan, we supposed to use 9.81, right?
Aha. Ah, A.
Tapi tak,
Untuk G ke A?
G, sorry.
Aha.
Lepas tu, dalam web assignment saya pakai nilai 9.81 tu. Lepas tu jawapan saya dapat 0.66. Dia kata salah. Lepas tu saya pakai 9.81, nilai dia 0.67 baru dia bagi betul. So kalau dalam test, kita pakai 9.81 ke 9.8?
9.81.
Okay.
Okay.
So, web assignment tu macam exceptional lah.
Tak sure lah tu soalan nombor apa nanti saya tengok balik. Saya tak perasan pula dia tak boleh. Soalan
nombor 9.
Nombor 9. Sekejap saya tengok.
Chapter 3.
Thank you. Nama awak siapa Saya tak perasan siapa yang bercakap tu.
Siti Hajar.
Okay, Siti Hajar. Sekejap Nombor 9 Siti Hajar. Sekejap tahu. Okay, soalan nombor 9 web assign. Soalan nombor 9. Chapter 3, sorry. Aduh. Silap. Assignment chapter 3. Alah. 9.8. Hajar, untuk web design memang kena pakai 9.8 lah. Saya pun baru perasan. How did everyone else do the questions? Pakai 9.8 ke 9.81?
Kebanyakan contoh dia bagi video turun tengok tu pun dia pakai 9.8 kebanyakan.
Okay. So untuk web design pakai 9.8 lah. But for your exam pakai 9.81. Tak tahu kenapa dia pakai 9.8. Sekejap. Ada tak constant dalam buku? Belah untuk web assign anggap macam tu je lah 9.8. Saya pun tak perasan before this. 9.8.
Okay, thank you, Doctor.
Okay, welcome. 9.8. Ouch, ouch, ouch. Kalau tak silap saya dalam modul ni cakap 9.81. So exam patutnya 9.81 lah. Chapter 1 dah janji tak? Chapter 1 dah janji ke tak? Tak ingat. Page 25 cakap 9.81. Tak apalah, untuk exam pakai 9.81 I'm sure that will be accepted. Kalau tak, I will fight for you lah. But shouldn't be a problem lah, it's just a constant. Okay. And beza 0.01 je. Okay je. Tapi web assign tu mengada-ngada, so just follow 9.8. Is everyone back? It's 3:46 dah. Okay. Let's do this. Okay. I hope everyone is back because I'm gonna continue. Sekejap, nak spot check lah. Siapa Is... Oh, terus tunjuk muka. Okay. Is Mashita there?
Yeah.
Okay. Kumaira?
Yes, Doctor.
Oh, okay. Semangat. Shazia?
Yes.
Yay. Okay.
Ada.
Okay dah tu. Okay lah, spot check berjaya. Okay, lepas tu buat slide balik. Okay, let me share my screen.
Kau pun ada, Doktor.
Okay, thank you. Slide. Okay, let's continue with chapter 4. For this chapter, we are dealing with work, energy and power, mechanical potential energy and conservation of energy. Kenapa kita belajar chapter 3? Kita akan pakai dalam chapter 4. Macam biasalah, always related. So after completing this chapter, you must be able to define and calculate work by force. So tadi kita belajar force je. Now we are using force to calculate for work. Chapter 3, free body diagram, forces. Chapter 4, work. Work is related to force, okay? So relate between work, energy and power, state conservation of energy and solve related problems. So iklan kejap, work, energy and power. So okay, so work done by a force. When a force is applied on an object, there is a change in velocity. So kalau awak tarik objek ni, if you pull a box by a string, the box will move to the right, kan? So you will have displacement. Displacement is given by D. So when you have displacement and you have force acting in the same direction as displacement, you have positive work. So again, you have force, you have displacement, you will have work. But F and displacement must be parallel. Okay? So the equation is work is a dot product of F and delta X or displacement. And mana pergi? And remember, dot product gives you F cosine theta. Kalau cross product, it will give you F sine theta. So here it's a dot product, F cosine theta multiplied with the change in displacement. So why is it F cosine theta? Because we want to find the parallel component to the displacement. Okay, you have a force acting this way, kan? If you were to resolve it, you will get Fx in this direction, which is just F cosine theta, and you will get Fy. You will get Fy. Kenapalah saya punya macam tu? Fy, which is F sine theta. For work done, you are only interested in Fx, which is the parallel component of force, F that is parallel to delta X. So you are only interested in F that is parallel to delta X. FY ni you don't care. If it's perpendicular, you don't care. Okay? If it's parallel, yes, you want it. That is work done. So work done is a scalar quantity. Why is it a scalar quantity? Because you are only interested in the parallel component, which means that if it's a positive, it's going to the right, it's going in the same direction as displacement. If it is a negative, it is going in the opposite direction as displacement. We will talk more on that. Jangan confuse lagi, jangan panik. It is a scalar quantity because you don't want the angle at all. You just want it to be parallel. No angle. Kalau no angle maksudnya no direction lah kan. So direction is only parallel to displacement. So it is a scalar quantity. Okay, so the equation for work done is F dot product of F and delta X, or you can expand it and give me an equation like this. F cosine theta multiplied by change in displacement. Okay, next. So definition of work done. Work done by the force on the object. So force does work on the object and gives it displacement. Work is done on the object, but by force. Okay, force is doing the work, force is doing work on the object, by force on the object. And the units is Newton meter. Why? Because this guy is a Newton and this guy is a meter, so you get Newton meter. Or you can also say joules. Joules is also the unit for energy. Okay, sama. The unit for work and for energy is the same. Or you can use Newton meter, boleh. Okay, so no work is done if F equals to 0. From this equation, we can say kalau F equals to 0, yes, work done is 0. If cosine theta is 0, yes, work done is 0. If displacement is 0, yes, work done is 0. When does cosine theta become 0? It becomes 0 when theta is equal to 90, or it is perpendicular to the displacement. So perpendicular force gives you 0 work. Again, Fy, kenapa lah macam ni? Okay, so Fy will always be 0. F that is perpendicular to displacement will always be 0. Always look at your displacement. Whatever that is perpendicular to displacement will give you 0 work done because it's not moving in that direction. Okay. Oops.
Doktor, kenapa dia x-axis je? Contohnya kalau kita angkat barang ke apa, dia tak ada work ke macam mana?
So work done in the y direction. Boleh x-axis, boleh x-axis, boleh y axis. Boleh.
Okay. Thank
Dia
you.
just kena parallel je. Okay, let's talk about that situation. Sekejap, kenapa saya nak padam pakai ni? Padam pakai pensel lagi laju. Okay. So let's take a look at the situation. I have a box. I push this box here and it is moving this way. And I have a box here. I am pushing it upwards. So this is my force. And the displacement is this way. Boleh? Dua-dua, sorry, this will give me y. Dua-dua will give me positive work done. This guy will also give me positive work done. What is the important thing to take away from this? You only need to care force that is parallel to displacement. Itu je yang kena kisah. Force that is parallel to displacement? Yes. Force that is parallel to displacement? Yes, you get work done. Tak kisahlah angle macam mana pun. Kalau macam ni, on an incline, force is this way, displacement is this way. Yes, you get work done. Walaupun sengit-bengit. Asalkan parallel. Asalkan F is parallel to your displacement, you will get work done. Okay, so let's talk about when it becomes positive and when it becomes negative. If it is in the same direction as displacement, for example, F is in the same direction as X. If you extend this line, the angle between them is 0, betul tak? So angle is 0. Angle that is 0 to below 90 will give you a positive work done. Okay, let's see what happens.
Doktor,
Yeah.
Displacement kan ada arah kan?
Ada?
So if dia pergi ke depan, then dia ke belakang balik, ada kerja.
Tak dengar, ada putus balik.
Sebab displacement dia akan jadi kosong.
Displacement jadi kosong. Okay, so kalau displacement kosong, work done kosong lah. Remember?
Tak ada kerja lah.
Tak ada kerja. Buat kerja sia-sia nama dia. Betul tak?
Okay, thank you Doktor.
Okay. So, macam mana tadi? Okay. So, work is positive when the angle between F and displacement is less than 90. Okay, kalau angle ni less than 90 lah kan? Because 90 is this way, betul tak? So, anything that is this angle will give you positive work. So, if F is this way, yes, dia punya component akan resolve this way and Fx will be in parallel with in the same direction as displacement. If my F is, sekejap, kita pakai warna lain. Let me write this nicely so it's not confusing. Okay, so let's say we have angle 30. Okay, angle 30. If I were to resolve this, it will become F cosine 30 and F sine 30. Okay, the component that I'm interested in is only this guy. So my work done is F cosine 30 times displacement. Okay, let's say dia bergerak sebanyak 2 meter. So this guy becomes 2 meter. Macam tu. I don't care about perpendicular component. So here work is positive sebab apa? Because it is in the same direction as X. What happens if my F is in a different direction? Angle dia lain. Let's see. What happens to it? Okay, kita punya displacement sama. Okay, macam mana nak buat lagi sama? Okay, let's say saya ada piano lah. Piano punya example nanti. Box lah, box. So box ni berat gila. So Reza cakap nak tolak box ni walaupun berat, nak tolak. So this is F by Reza. Okay, Reza kasih 10 Newton je, alamak sikitnya. Box ni punyalah berat, I think it's 100 kg. So the box slides downwards. So displacement is delta X. Pernah tak kita tolak barang tapi dia berat sangat, kita slide ke bawah. So that is what happens to Reza. The box slides down, displacement is going down, tapi Reza punya force upwards. So it's in the opposite direction. What is going on? The work done by Reza, force, kita panggil Reza force lah, is negative. Sebab F dia dengan X dia terbalik in opposite direction. Tadi kita punya F in the same direction walaupun dia ada angle. This time, walaupun dia parallel, it is in opposite direction. So now, work done by Reza force is negative. Okay, so what is the angle between Reza force and displacement? The angle is 180. Tadi 0. Now it's 180. Sorry, tadi 30. Macam mana nak tahu 180 tu? So Reza force is like this, kan? And your displacement is this way. What is the angle between the two? It's half a circle, so it's 180, opposite direction. Okay. Okay, what should you take away from this situation? Anything that is in the same direction, the force that is in the same direction as displacement will give you positive work. The force that is in opposite direction as work, apa yang cakap? Force that is opposite direction as displacement give you negative work. Okay, opposite, negative. Same direction, positive. Okay, with that, I shall end my class for today. We will continue with an example next
Sekejap
time.
Doktor, ada soalan Doktor.
Okay, yeah.
Yang untuk work done tu, dia memang kena F cos theta tu instead of, contohnya kalau dia ada friction ke, kenapa dia tak guna F net instead of F cos theta?
Kenapa dia pakai F net? Okay, untuk
Contohnya
soalan,
kalau macam tu, dia ada friction dan sebagainya. So, F dia kan lain nanti.
ada banyak F kan? Ada F net kan? Okay, faham. kita punya soalan ni dia boleh tanya what is the work done by external force, what is the work done by gravity force, what is the work done by friction, boleh what is the work done by Fnet, boleh. So tak nak kena tahu Fnet, cara nak cari Fnet, tak nak kena tahu what is your friction, what is your gravity force, what is your external force, because the question can ask you what is the work done by gravity force, what is the work done by external force, what is the work done by friction force, boleh. Is that clear?
Okay, itu je. Thank you, Doktor.
Okay. Any other questions for me?
Doctor, so work done, it can be both positive or negative values, but
yes.
It is still considered a scalar quantity. We just get a negative value if theta is above, between 90 and 180 lah. Right?
Yes, it's still a scalar quantity.
Thank you,
Walaupun confusing sikit, but it's a scalar. Okay. Okay, that's it. Okay, so I'll see you guys on Thursday. Kan? Thursday kan? Yep. Okay, bye. Have a great day. Don't forget to eat.
Thank you, Doktor.
Bye.
Thank
Thank
you,
you,
Doctor.
Doktor.
Thank you, Doctor.
Thank you, Doctor. Thank you, Doctor.
Saya baru baca mesej ni, tak dapat acah berat.
Thank you, Doktor.
Thank you, Doktor.
Okay, you're welcome. Bye.
Bye-bye.
Pak Is, turun.
Sakit ni. Pekak. Sekejap.
Meeting pets.
Tahulah Sat-Sat.
Expo kan?
Sabarlah. Asal belum masuk.
Thank you,
Bye,
Doctor.
Doctor.
Merah. Kita kena tutup.
You're
Thank you, Doktor.
welcome. Bye.
Bye.
Yang ni tak nak keluar kelas ni, kenapa ni? Dah habis kelas dah, dek.